Continuing our look at random variables, today we will be transforming random variables. And in this next video of 6.2, we'll be combining random variables. And we're looking at how these transformations are going to affect the mean and the standard deviation and variance. And what I hope you notice is that this is really nothing new. It's things that we saw much earlier in this course. So we're going to be looking at linear transformations, so multiplying and adding. Then we're going to be combining the random variable. So in 6.1 we looked at how to calculate the mean and the standard deviation for different random variables, and then we practice it. Back in chapter 2, when we were exploring data, we looked at how adding and subtracting constants or multiplying and dividing by constants affects the measures of center and the spread. And here's a summary of what we found. So adding a constant adds to the measure of center. Makes sense. It gets bigger by that amount. It doesn't change the shape or the measure of spread. It simply takes the whole distribution and slides it horizontally on our x-axis. Multiplying each observation by a constant multiplies every measure of center by b, and it multiplies the measure of spread by the absolute value of b, because we want the spread, the measure of spread, the standard deviation to be positive. So we multiply by the absolute value of b, and the overall shape doesn't change. The scale of our measurements just does. So let's look at a guy named Pete. He's giving there must be 2 passengers to run the trip, and the vehicle will hold up to 6. And we collect data and we find that this is our probability distribution. The probability that he has 2 passengers on any given half-day trip is 0.15, so on. Here we go. Here's a histogram showing this probability distribution. And notice this is discrete. We have discrete values for our random variable. We can calculate, using the skills of last section, the mean and the standard deviation. Now, we know that Pete charges $150 per passenger. Our new probability distribution would be 150 times these old values. 150 times 2, 150 times 3, 150 times 4, so on. That's where this collected row comes from. The probability is still the same. We can look at a histogram. Notice the overall shape has not changed from the original, but the mean and standard deviation have. We're going to compare the shape, center, and spread of these 2 probability distributions. So notice that the shape doesn't change. The center has been multiplied by 150. And the standard deviation also has been multiplied by 150. And that can be summed up with this orangish box right here. When we multiply or divide each value of a random variable by something, we take the measure of center and location, mean, median, quartiles, percentiles, and we multiply by b. We multiply or divides the measure of spread, whether it's range, IQR, standard deviation, by absolute value b. And multiplying does not change the shape of the distribution. And on a side note, multiplying a random variable by b multiplies our variance by b squared, because remember, the variance is the standard deviation squared. Okay, so we've got Pete's Jeep tours again. We've got the amount of money he collected. We've got the mean, the standard deviation. Here's our shape. Let's say it costs $100 for Pete to buy his permits, get gas, to have a ferry pass so that he can transport people around. So now we're looking at profit instead of amount of money collected, so we had to subtract 100 from each of these. Here's our new histogram. Here's our new mean, our new standard deviation. Compare the shape, center, and spread. Write down a quick statement about how you think each of these 3 things has done. So how have these changed? Well, the shape, It's the same. The mean has been decreased by 100, and the standard deviation hasn't changed. So we can summarize what adding and subtracting a constant does as follows. Adding the same number, or subtracting, that would be a negative addition, to each value of a random variable adds that same amount to the measure of center. It does nothing to the measure of spread, and it doesn't change the shape of the distribution. We just saw these things in the previous example. So what we're seeing here is it doesn't matter if we're looking at individual data values, like back to chapter 2, or random variables and their probability distributions. The effects of these linear transformations, these additions and these multiplications, they behave the same way. If y is a new probability distribution, a new random variable, and we get that by taking our old random variable and multiplying by x, add a, multiply by b, add a, then the probability distribution of y will have the same shape as x. The new mean will be a plus b times the old mean, and the new standard deviation will be the absolute value of b times the old standard deviation. And this is where we will stop for today's video. In the next video, we'll look at how we could combine random variables together and what that means and what implications that has on mean and standard deviation.